Okay, so today while you have a substitute, everybody's doing virtual. Remember, the first thing you need to do is watch the video and take some notes. Then complete your My Math Lab. It is due by the end of class. If you finish early, play math multiplication games. Remember, the link is on Google Classroom. 2 rules to keep in mind here. Computer screen facing the teacher. Headphones are for the video lesson only. No music. If there's any problems, the sub will let me know, but I imagine you guys will have everything under control. So today's lesson is factoring polynomials with an a greater than 1. Remember a while back I said that any time that we're going to be factoring a trinomial, it's going to be set up like ax squared plus bx plus c. In this lesson here, we did an a of 1. Now the a is going to be greater than 1. So it's going to make us have to do a couple extra steps. So first of all, I'd like you to try to remember how we do factoring by grouping. Remember, when I'm grouping things together, I'm checking to see if there's a GCF that they have in common. In the first pair, I have a GCF of 4y. So the 4y goes on the outside, and I'm left with 2y minus 3. In the second equation, I want to end up with 2y minus 3, so I want to factor out a 5. I factored out a positive 5, which gives me 2y minus 3. Then, because the things inside the parentheses are the same, I can smash together the things outside the parentheses. Remember, this is like FOIL. And write one of the pairs inside the parentheses. That is my factored answer by grouping. So, if I have a trinomial, ax squared plus bx plus c, I'm going to use a factor sum table just like before. However, the factor, that's an ugly S, the factor is going to come from the a and the c. We're going to multiply them together. So we're looking for factors of 40 that add up to 13. Now, we can make a whole list of these here. Factors of 40 that add up to 13. We got 1 times 40. We've got 2 times 20. We've got 4 times 10. And we've got 5 times 8. Checking through those, which adds up to 13? 5 times 8. Now, remember back when we were factoring using a factor sum table, we would directly go x plus 5, x plus 8, and we were done. If you notice, if you were to FOIL this, we don't get 4x. That doesn't work. So, this is where the factor by grouping comes in. When you have an a greater than 1, you're going to take the middle term and you're going to break it into those 2 pieces, a 5x and an 8x. And if you notice, 5x plus 8x equals 13x. Okay, now, everything else is the exact same as it was. So we've got 4x squared plus 5x plus 10. So you notice what we just wrote is completely equivalent to the previous statement. So now the next thing we're going to do is we're going to factor by grouping. So in the first pair, I can divide out an x. So I'm going to put the x on the outside. That gives me 4x plus 5. So when I factor out this second pair, I want it to give me 4x plus 5, so I'm going to divide by 2. So plus 2, 4x plus 5. What I got on the insides is the same, so I can smash together. That gives me x plus 2 and 4x plus 5. If I were to FOIL that out, I would get the original question. Not too bad, is it? I've got a whole bunch more examples, so if you're not getting it yet, don't stress. Let's try this one. 10x squared minus 23x plus 12. So again, We're making ourselves a beautiful little factor sum table. We take the first number times the last number. That gives me 120. So I'm looking for factors of 120 that add up to negative 23. So let's list out all the factors of 120 that we can think of. I've got 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and 10 times 12. Which of those adds up to negative 23? Well, we're going to have to throw in some negatives there. If we throw in negatives, that one is going to work. So remember, I'm splitting the middle term into those two pieces, a negative 8x and a negative 15x. These pieces stay the same. And now I factor by grouping. I can divide out a 2x and I can divide out, remember I want this to equal 5x, see that negative there? So I should probably divide by a negative 3 to make sure it equals 5x minus 4. Alright, so now I can smash together because these are the same. 2x minus 3 times 5x minus 4. Hope you're getting the hang of this. Let's do some more. Take a look at this problem here. Again, we've got ax squared plus bx plus c, so we can make a factor sum table. We're looking for factors of 210, remember multiplying these two together, that add up to negative 41. So 2 times 105, 3 times 70, 5 times 42, 6 times 35, and I think that one might work if I make them both negative. Beautiful. So again, split the middle term into the negative 6x and the negative 35x. The first and the last stay the same. Now I can do some factoring by grouping. I can divide by a 3x. That gives me 7x minus 2. Again, I want this to give me 7, so I'm going to divide by a negative 5. Gives me 7x minus 2. These two pieces are the same, so I can smash 3x minus 5, 7x minus 2. Final answer. Remember, if you want to check it, FOIL it, and you should get what you started with. Alright, if we look at this problem, ladies and gentlemen, you notice that it's not ax squared. So the first thing I start thinking about is there a GCF? Remember, the first thing you should always check for is a GCF. And in this case, we have a GCF of x. So I factor out the GCF. And now I see I could try a factor sum table. Let's see if it'll work. I'm looking for factors of 3 times 10 that add up to 17. So let's see here. I think that one's pretty easy. 2 times 15, right? So remember, split that middle term. It doesn't matter which order you write the middle terms in. There will be a GCF to factor out when you group. Here, I can factor out an x. That gives me 3x plus 2. Here, I can factor out 5. That gives me 3x plus 2. Since what's in the parentheses is the same, I can do some smashing. And I bet you're really starting to get the hang of it now. Got 2 more examples for you that kind of like stretch what we're thinking about. Take a look at the first one. 4x squared plus 24x plus 32. First thought always needs to be, is there a GCF? And in this case, the GCF would be 4. So that gives me an x squared plus 6x plus 8. Now my a is equal to 1. So I'm simply going to find factors of 8 that add up to 6. 2 times 4 is going to do it for us. Remember how we write that. Keep the GCF on the outside. X plus 2, x plus 4. You can jump straight to that. All right, final example. I'm sure you're getting bored of this, but this one's really important. Factors of negative 15, 3 times negative 5, that add up to 7. 1 times 15, 1 times negative 15, 3 times negative 5, negative 3 times 5. What? None of them are adding up to 7. You guessed it. It's prime. We can't factor it. So, why don't you do some practice? My Math Lab. Remember to always show your work, and when you finish, some multiplication games. Keep it all educational, guys.